Point of sale medium level. Here's the high-level overview process that we covered in the high-level overview. And here's the overall key figure flow in a little bit more detail. Step 1A, we load point of sale data at an aggregated level, may include point of sale quantity, revenue, or price, as well as the customer's inventory position. Step 1B, we disaggregate the point of sale data to weak, prod, low, cost, or the appropriate planning level for your business. Step 2, we adjust the global point of sale data with either local files and/or manual updates. Step 3A, we calculate a point of sale forecast quantity with the point of sale quantity plus the statistical forecast model. Step 3B, we calculate an expected customer receipt from sales order history and customer lead time. Step 3C, we calculate the point of sale projected inventory from the point of sale forecast and the point of sale receipts. In step 3D, we calculate a point of sale days of cover from point of sale projected inventory and the point of sale forecast. Step 4, we use this point of sale days of cover as a critical input to our forecasting tools. Step 1, we bring in the global point of sale data at an aggregated level. Currently, that's at weak, prod, low, strat, or sold to, but we think that'll change. Not a fully automated process, but it could be. We instantly break it down into the IBP standard planning level, in this case, weak, prod, low, cust being shipped to. So that gives us the point of sale quantity, revenue, price, inventory, and inventory cost, if the customer supplies it, obviously. Step 2, we can bring in the ad hoc point of sale data at an aggregated level. Currently, this is also at weak, prod, low, strat, or sold to. Again, not fully automated, but it's pretty fast from the customer file to IBP. Demand planners also have the ability to adjust the point of sale manually. Again, we're finding big discrepancies between the data files, global versus ad hoc. So we have some pretty reliable and easily updatable point of sale data. So what do we do with it? Step 3, enter point of sale days of stock. Or, how many days does a customer have of our product? Issue number 1. Even though we know how much they have sold, we don't know how much they will sell. The Coleman example is, we sell tents in May, not March. So historical point of sale quantity needs to be converted to a point of sale forecast quantity. Fortunately, demand planners do this every month with statistical forecasting. They just use our sales order history instead of their point of sale history. Enter point of sale forecast quantity. Here, the point of sale quantity adjustment we've seen before, but it's the historical point of sale that we loaded from the customers. The point of sale forecast quantity is the output of a new forecast model using point of sale quantity adjustment as an input. The only difference between this model and the one you use for your SOH is that input and output. You can run the same algorithms, same time periods, etc. Point of sale ex post quantity is also an output of that new forecast model, using point of sale quantity adjustment as an input. We can use this to see how well the model is selecting a future point of sale quantity, forecast quantity, and even calculated a weighted MAPE, just like we do today with our sales order history adjustment quantity and our stat forecasting quantity models. So to recap, customer has been selling this, and our statistical model is telling us that we expect them to sell this in the future. Issue number 2. We need to know the customer's projected inventory. We know how much they have right now. That's the point of sale inventory quantity. We don't know how much they will have 2 months from now. Point of sale projected inventory quantity. Enter point of sale projected inventory quantity. Point of sale inventory adjustment is the best answer we have as to how much of our product a customer has at their location. It should only be populated in the current and past periods, not the future. SOH quantity adjustment for PS point of sale is a little wacky. Basically, we need some way to put in future supply from us to the customer, which is an SOH quantity. But in order to future-proof, we made it just its own key figure, comes from SOH adjustment. But this way, if you need to adjust that number, for example, take into account customer lead time and not impact the sales order history adjustment directly, we have this key figure. Point of sale forecast quantity, we've talked about this one already in issue number 1. Again, it is what we have statistically forecasted to be the future point of sale quantity. POS projected inventory quantity is a calculation of the previous key figures. For the current week, it is point of sale inventory adjustment plus sales order history quantity adjustment for POS less point of sale forecast quantity. In the future weeks, it is the point of sale projected inventory quantity from the previous period plus the sales order quantity adjustment for POS less the point of sale forecast quantity. Let's do an example. Walmart has 1,000 in inventory right now. We expect them to sell 335, so they have a projected inventory at the end of the period of 665. Walmart expected to have 282 at the end of period technical week 36A. We have an actual sales order and we expect them to receive 3,000 from us. We expect them to sell 324, therefore the projected point of sale inventory is 2,958. Issue number 3. Now we need to take all this and put it into a days of stock number. Point of sale days of stock is a calculation of the previous key figures, point of sale forecast quantity, and point of sale projected inventory quantity. It will start consuming the next week's point of sale forecast, assume 7 days in the week, and will allow time periods with zero demand to be included in the calculation. More on this later. Let's practice. Walmart has 665 in projected inventory at the end of technical week 34, and we are calculating 20 days of stock because we have a point of sale forecast of 335 next week, which adds 7 days and leaves 330 in inventory. We have a point of sale forecast of 48 the next week, which adds another 7 days, which leaves 282 in inventory. And then we have a POS forecast of 324 the next week, which adds 4 days and leaves 0 in inventory left. Coverage can become more complex. It's the national sport of supply planners everywhere. Here are just some of the questions that come up around days of stock. Just be aware that we may want to look at those details in the future. Not now. Right now, it is handling it this way. Demand starts to consume inventory in the next week. The aggregated recalculation is probably accurate, but we're not 100% sure. 0 demand is included in the calculation, and you cannot consume negative inventory. Step 4. Using point of sale days of cover effectively. Although forecasting models like gradient boosting can use point of sale days of cover, be aware that it takes a lot of data in order to train the model. You might be better off to just look at the data intuitively first. A simple graph could explain a customer's buying behavior more easily. For example, converting a customer order to days of cover and identifying at what level they reorder may be the quickest solution. As always, thanks for watching Practical IBP, and don't forget to like and subscribe.